The Limburg area is full of possibilities, from keeping livestock and mining precious rocks to ambitious and groundbreaking scientific installations. The area is designated as a possible location for the Einstein telescope, and many cows are being held on top of the rock slopes by farmer Jean Donnieux. But the project and cows are under danger, as the carbonate rocks present in the area are very fractured and only limited data is available. To make sure the right preventive measures are taken, we aim to determine the rock and discontinuity properties to ensure a successful construction of the telescope and ensure the safety of Jean Donadieu's cows.
The studied outcrop Cascade de Chanxhe is located in the eastern extent of the Dinan line, which was formed during the Variscan orogeny. The studied rock formation consists of sandstone, which is part of the Evier formation that dates back to the Upper Devonian and has some parts that have undergone some slight metamorphism. The outcrop was 80 meters wide, approximately 7 meters tall, and goes from the southwest to the northeast with a dip angle of 88 degrees. The properties of the sandstone, like bedding thickness and number of fractures, were different throughout the outcrop, and therefore the outcrop was split up into 6 beds. In the sketch of the outcrop, the beds are numbered 1 to 6 from the top to the bottom of the outcrop. Beds 1 and 3 have thin bedding and contain a lot of discontinuities. The other beds have thick bedding and contain fewer discontinuities, and bed 6 is particularly thick. Below the slope some rubble was present, and there is water dripping out of the third bed, causing the beds below to be wet.
The discontinuities can be grouped into 4 general sets and with orthogonal networks. As shown in the stereotype plot here, joint set 1 is parallel to the bedding, which is very close to the circle border of the Schmidt net. Joint set 2 is represented by red lines, oriented perpendicular to the wall. Joint set 3 is represented by green lines in the plot, and it is parallel to the wall. The last joint set 4 is a tilted plane and is drawn by the blue line in the stereo plot. The presence of 4 joint sets suggests a higher possibility of potential slide planes. No visible persistence for joint set 1 is observed. Other joint sets have slow persistence on average. However, joint set 2 has medium persistence. This suggests that large-scale sliding is not likely to take place. The aperture for the joint sets range from wide open to very wide open, allowing water to flow within freely. The spacing of the joint sets also varies among different beds. The spacing of the joints is generally wide, especially for beds 2 and 6. However, beds 1 and 3, which are the layers with thinner beddings, have closer spacing and worse quality compared with other layers.
The discontinuities and rock properties affect the stability of the rock outcrops found in the area. The stability of the rocks was assessed by performing a slope mass rating and by assessing different failure modes on a stereo net. The slope mass rating was performed on the 6 characteristic beds. As shown in the table, there is a risk of wedge failure in all separate beds. The thinly bedded layers are also at risk of toppling and under wet conditions can experience plane failure. Assessing plane and wedge failure by plotting the discontinuities on a stereo net shows a low risk of plane failure and a moderate risk of wedge failure, indicated on the stereo net by the points in the pink area. The risk of plane failure will be low, as persistence is very low for one joint set and highly slope dependent for the other joint set. In the Cascade de Chanxhe area, wedge failure might therefore occur and local plane failure can happen. The rubble found beneath the outcrop supports these conclusions.
In conclusion, wedge failure and local plane failure will have a strong impact on the Einstein telescope, as the tunnels will need to be reinforced. This is also the case for Jean Donnieu's cows. To ensure their safety, it will be wise to reinforce the slope to prevent failure.